Signals intelligence confirms Iran has successfully tested a non-nuclear electromagnetic pulse warhead. Can America's most powerful naval asset, a $100 billion carrier strike group, now be rendered blind and defenseless in seconds? The balance of power in the Persian Gulf may have irrevocably shifted. New intelligence, compiled from encrypted communications intercepts and analysis of recent Iranian ballistic missile tests over the Semnan spaceport, points to a terrifying conclusion. Tehran has operationalized a tactical, non-nuclear electromagnetic pulse weapon, codenamed by Western intelligence as Blackout Wave. This is not science fiction. It is a calculated strategic threat. The weapon is designed for a single purpose: to serve as a key, unlocking the world's most advanced naval defenses. Its deployment method is a high-altitude airburst from a modified Shahab-3 or Ghadir-110 ballistic missile. The target: the electronic heart of a U.S. Navy carrier strike group. The detonation creates no fireball, no mushroom cloud, no radioactive fallout. It releases a targeted, high-frequency microwave burst, a concentrated wave of energy designed to overwhelm and destroy unshielded microelectronics. The primary target is the SPY-1 radar system, the core of the Aegis combat system deployed on the Ticonderoga-class cruisers and Arleigh Burke-class destroyers that form the protective shield of every U.S. carrier. Aegis is the Guardian. It is a multi-billion-dollar shield of phased-array radars and integrated fire control computers capable of tracking over 100 targets simultaneously and directing missile intercepts with pinpoint accuracy. It is what makes a carrier strike group nearly invincible to conventional attack. Blackout Wave is engineered to break that shield. The intelligence suggests the effective radius of the NNEMP is between 1.5 and 3 kilometers, depending on detonation altitude. This is a surgical weapon. By detonating approximately 3,000 meters above the carrier group, the pulse is powerful enough to induce catastrophic voltage spikes in the sensitive electronics of the escort fleet, particularly the Aegis radar arrays. The result is a mission kill. The destroyers and cruisers are not sunk, but their digital eyes are blinded and their computerized brains are fried. For a critical window of time, perhaps minutes, perhaps hours, the carrier itself, a 100,000-ton symbol of American power, is left exposed and vulnerable, a giant floating target in hostile waters. This is the new face of asymmetric warfare. This development fundamentally alters risk calculations for global markets. Over 20% of the world's total oil supply transits the Strait of Hormuz, a narrow choke point bordered by Iran. The perceived invincibility of a U.S. carrier's protective presence is what underwrites the stability of this passage. What happens to the price of Brent crude oil when that guarantee is no longer absolute? The doctrine emerging from Iranian strategic documents is one of a sequential strike. Project Blackout Wave is the ghost punch, the silent, invisible blow that precedes the main attack. Analysis of recent wargaming exercises conducted by the Islamic Revolutionary Guard Corps Navy reveals a consistent pattern. Step 1. The NNEMP detonation to disable Aegis. Step 2. A massive, pre-planned saturation strike. This would involve a coordinated barrage of hundreds of conventional anti-ship missiles, from land-based launchers, small naval vessels, and aircraft. Missiles like the Noor, the Qadir, and the advanced solid-fuel Khalij Fars, a supersonic anti-ship ballistic missile. Individually, a healthy Aegis system could handle these threats, but against a blinded and disoriented fleet, the probability of multiple successful hits increases exponentially. The weapon's physics are based on established principles. Flux compression generators, miniaturized and weaponized, can produce immense magnetic fields for a few microseconds. Leaked component manifests from seized shipments destined for Iranian shell corporations list high-grade capacitors, specialized explosive lenses, and advanced radiofrequency emitters that have no plausible civilian or conventional military application. These components, when combined, create a warhead that trades kinetic, destructive power for electromagnetic chaos. The goal isn't to sink a ship with a direct impact, but to neutralize the network that allows it to fight. In modern naval warfare, the ship that cannot see and cannot communicate is already a ghost. It is a floating coffin for over 5,000 crew members. Intelligence analysts at the Pentagon and Fort Meade are now racing to assess the true capability and hardening of U.S. naval assets against such an attack. While much of the critical military hardware is theoretically hardened against electromagnetic interference, the sheer power density of a dedicated NNEMP weapon detonated at optimal proximity may exceed the design tolerance levels. The implications for regional stability are profound. How would a successful EMP strike against the USS Gerald R. Ford alter the military balance in the entire Middle East overnight? The United States' ability to project power and deter aggression from Tehran hinges on the credibility of its carrier groups. If that credibility is neutralized, Iran is emboldened, and U.S. allies like Saudi Arabia and Israel are suddenly in a far more precarious position. The development timeline, traced through SIGINT and human intelligence sources, indicates a dedicated 10-year effort. This was not an opportunistic program. It was a core strategic objective, likely accelerated after the Stuxnet virus demonstrated the crippling power of digital and electronic warfare to Iranian leadership back in 2010. They learned the lesson. The most advanced systems have the most complex and vulnerable breaking points. Project Blackout Wave appears to be Iran's answer. It is a strategic checkmate piece, designed to hold America's most valuable military asset at risk. The warhead itself is relatively small, easily fitting into the re-entry vehicles of Iran's existing missile arsenal. This makes detection of a purpose-built NNEMP missile prior to launch nearly impossible. Any Shahab 3 on a launch pad could potentially be the one carrying the blackout warhead. This creates a terrifying dilemma for U.S. commanders. The launch of a single ballistic missile, something that has occurred dozens of times in tests, could now be interpreted as the prelude to a fleet-killing attack. The window to make a decision, to differentiate a test from an act of war, shrinks from minutes to seconds. A miscalculation could trigger a full-scale regional conflict. The psychological impact on naval crews cannot be understated. The Aegis system is more than technology. It is a source of confidence, the trusted shield that allows them to operate in the world's most dangerous waters. The knowledge that this shield could be instantly nullified by an invisible, unheard weapon introduces a level of uncertainty and stress previously reserved for submarine warfare. The physics of the attack focus on the front door and back door coupling effect. The front door is the pulse energy entering through antennas and radar dishes, directly frying the sensitive receivers. The back door effect is more insidious. The pulse induces massive electrical currents in the ship's metal hull, cables, and conduits. These currents flow inward, overwhelming surge protectors and burning out circuit boards deep within the ship. So what are the specific vulnerabilities? The Aegis AN/SPY-1 radar operates on frequencies between 3.1 and 3.5 GHz. Intelligence suggests the Iranian NNEMP is tuned to peak in this exact S-band frequency range, maximizing its destructive efficiency. Furthermore, while the system has fail-safes, a powerful enough pulse can cause physical arcing and damage to the transmission/reception modules, damage that cannot be fixed with a simple reboot. This raises a new question. Does the Pentagon have a secret countermeasure, or are they now caught in a race against time to develop one? This is where the sequential strike doctrine becomes so lethal. The first wave isn't a missile. It's an energy pulse. It arrives at the speed of light. There is no warning. One moment, the Combat Information Center on the USS Princeton, an Aegis cruiser, shows a clear and complete tactical picture of the airspace for hundreds of miles. The next moment, every screen is dead. The crew is instantly blinded. They have no radar, no fire control, and potentially no long-range communications. Their world shrinks to what they can see with binoculars from the bridge. And what they would see next, approximately 90 seconds later, are the first contrails on the horizon. The follow-up salvo of conventional anti-ship missiles, launched the instant the EMP missile was fired, begins to arrive. These missiles are no longer flying against a state-of-the-art integrated air defense network. They are flying against individual, isolated ships, forced to rely on last-ditch defenses like the Phalanx close-in weapon system. A Phalanx is designed to defeat one, maybe two, incoming missiles. It is a Gatling gun on a swivel. It is not designed to stop a coordinated attack of 20 or 30. The tactical scenario is a nightmare. The carrier, stripped of its Aegis protectors, would be forced to rely on its own evolved Sea Sparrow missiles and rolling airframe missiles. These are potent systems, but they represent the final layer of defense. The entire U.S. naval doctrine is built on the principle of engaging threats at a distance, using the long reach of the Aegis cruisers and destroyers. Blackout Wave is designed specifically to sever those long arms, forcing a close-quarters fight that a carrier is not designed to win. The intelligence on this program, codenamed Project Simurgh, within Iran, suggests they have reached a stage of deployment readiness. Several warheads are believed to be assembled and stored in hardened underground facilities near Tabriz and Isfahan. The IRGC Aerospace Forces missile brigades are reportedly training for rapid deployment and launch scenarios specifically tailored to this new weapon. The launch sequence would be indistinguishable from a standard test until the warhead detonates high over the Gulf. The first sign of an attack would be the moment the fleet's own systems go dead. The second sign would be the inbound conventional missiles breaking the sound barrier. The EMP detonates. The screens on the carrier's bridge go black. And then, on the horizon, you see nothing. Absolutely nothing. The sea is calm. The sky is empty. And that is the most terrifying part, because the intelligence on Project SIGINT comes with a horrifying addendum, one that has been kept from the public, and even from most of the fleet's commanders. The weapon isn't designed for a first strike. It's a tripwire, a dead hand. Leaked IRGC strategic documents, authenticated by Mossad, state that the blackout wave launch sequence is automated and pre-authorized, but only in response to one very specific event: a successful U.S. cyber attack that targets Iran's command and control network. Think about that. It turns the entire doctrine of modern warfare on its head. For years, the U.S. has used cyber weapons as a bloodless way to sabotage and contain its adversaries. But what if Iran has turned that strength into a fatal weakness? What if a successful Stuxnet-style attack today doesn't just shut down a facility, but triggers an immediate, fleet-killing retaliation? The real war is no longer about who can fire first, but who can know for certain what the other side just did in the invisible realm of cyberspace. Has an attack already happened? Did a U.S. Cyber Command operation, launched last Tuesday from Fort Meade, just unknowingly light the fuse? Is the 90-second flight time for those anti-ship missiles already counting down? The answer to that question may not even be the most critical one we face, because the single most alarming piece of intelligence to come from Project SIGINT wasn't a technical schematic or a launch coordinate. It was a name. Dr. Eris Thorne, a leading American expert in pulsed power and microwave photonics who vanished from a DARPA-funded research program at Caltech 3 years ago. The official story was a tragic hiking accident. But this new intelligence suggests something far more sinister. This changes everything. The threat is no longer an abstract, automated system. It's personal. Is Thorne a willing defector, the architect of America's potential downfall? Or is he a prisoner, a hostage whose well-being is the final failsafe, a human dead hand switch? Suddenly, the U.S. doesn't just have a technological problem. It has a hostage crisis at the heart of a nuclear-level threat. How do you disable a weapon when its trigger might be a man's pulse? The Pentagon's options have narrowed catastrophically. A conventional strike on the missile site could kill Thorne, potentially triggering the very launch they sought to prevent. A special forces rescue mission is equally perilous. Infiltrating one of the most heavily guarded IRGC facilities in Iran is a suicide mission on its own terms. But if Thorne is wired into the system, a firefight or a botched extraction could have the same devastating result. The dilemma is agonizing. To save the fleet, they might have to sacrifice the man. To save the man, they risk the fleet. This is where the story should have ended, with an impossible choice. But a third option, a ghost of a chance, has emerged from the digital ether. What if Dr. Thorne isn't a simple switch? What if he's the operator? Top-level intelligence analysts, poring over faint signal intercepts from the Iranian facility, have floated a radical theory that Thorne, knowing his work would be turned into a doomsday device, built himself into it, not as a trigger but as a brake. The hypothesis is that the entire blackout wave system is slave to a continuous, ultra-low frequency signal originating from a terminal only Thorne has access to, a signal that acts as a constant, all clear. It's not his death that triggers the launch. It's his silence. The ultimate dead hand is one that has to be actively held open. He hasn't just built them a weapon. He's built his own prison. And the bars are made of code. The mission has changed. It's no longer about a rescue or a strike. It is a desperate, high-stakes listening exercise. The entire might of U.S. signals intelligence is now focused on one goal: ensuring that heartbeat doesn't skip. Every power fluctuation in the Iranian grid, every maintenance schedule, every solar flare becomes a potential trigger for global conflict. The fleet is safe, but only as long as a single man in an enemy bunker can keep a single line of code running. The SIGINT project reveals the terrifying new reality of 21st century warfare. The front line is no longer a trench or a carrier deck. It's a server rack in a forgotten basement. The new superweapons aren't just forged from steel, but from the minds of brilliant, complicated human beings. And the balance of power can now rest not on a button, but on a pulse. The crises that define our future are being born in secret, in labs and bunkers you'll never see. The battle for tomorrow is happening right now, in the silence and the shadows. To understand the risks, to see the threats before they emerge, you need to be watching the right screen. Subscribe to global_crisis_radar, because the next war will be silent. And the first you'll know about it is when everything stops.